Today we're going to talk about the square root function. And just like we did with the absolute value function, our first step is to take a look at some points, some things, values we can plug in for x, and see what the y values are and see if we can notice any patterns. So number one, you always have to think domain. Is there anything that you can't plug in for x? Well, if it's a square root, we can only take the square root of a positive number and 0. So the first thing we're going to have to say is the numbers that we plug in for x are going to have to be greater than or equal to 0. And if you want to, you can of course write that as an interval instead. Remember, we would put a 0 with a bracket and read that out loud as from 0 to infinity. Either that inequality or the interval notation. Either one is fine for writing the answer. We will talk a little bit more about domain and range of these functions in our next video. But now that we have the domain, we can say, all right, since we can take the square root of any number bigger than 0, let's plug in some numbers, 0 or bigger, and see what we get. Now, if you notice at the table, I picked some very specific numbers. You absolutely can take the square root of 2, the square root of 3, but they're not pretty. So I just left them off the table. That doesn't mean they're not there. We'll pass right through them, but I didn't want to put them onto the table. So let's take the square roots of numbers that turn out to be nice and pretty. Like the square root of 0 is 0. The square root of 1. The square root of 4. The square root of 9. And so those are all our y values. And you can imagine that's just going to keep growing. The square root of 16, the square root of 25. That'll just keep going forever and ever and ever and ever. Which means that the range, we can see it started off when y was 0, and the y values will keep getting bigger and bigger and bigger and bigger as the x values get bigger and bigger and bigger. So the y values will keep growing forever. In other words, the range goes from 0 to infinity, just like the domain. Let's plot these points. Notice how all of my points are in the first quadrant, so I only graphed on the first quadrant. I'm going to plot the points 0, 0, 1, 1, 4, 2, 9, 3. And I want you to notice that the rate of change is not constant. Do not copy this as I draw it, but notice how the rate of change here, up 1 over 1, and then up 3 over 1, and then up 5 over 1. That's not the same every time, so those lines shouldn't be straight. What I'm going to do instead of drawing a straight line is draw a line with a little bit of curve, which is not that easy to do by hand, to get it to curve evenly. So I'm not looking for it to be perfect here. Just something that shows the line is curving. Try to hit the points as well as you can. And so we can describe what we see in the graph. That's what we call the behavior of the function. The first value we can plug in for x is 0, and when we do that, we get a y value of 0 also. And then as x gets bigger, y gets bigger also, but it gets bigger the y value gets bigger in a way that slows down over time. It gets less and less steep. Notice how it only took 1 unit the first time I wanted to go up 1, but then it took 3 units. This is just like the slope I showed you. And then it took 5 units. Next time it's going to take 7 units, and then 9 units, and then 11 units. Maybe you see the pattern there. So the graph is getting slower and slower as time goes by. Another thing I want us to talk about, which we didn't talk about last unit, but we're going to start mentioning every unit whenever we look at these functions, is something called the increasing and decreasing interval. It's trickier than it sounds. Increasing interval is when the function is going up from left to right. And when I say up, I mean upwards on the y-axis. But the tricky part is that when you're asked for an increasing interval, you're not being asked about y values. You shouldn't even look at the y-axis or the numbers on the y-axis. You're being asked about x values. The increasing interval is asking a question when, and whenever you see the word when, that always means x values. When is the function going up? Not how high does it go, not how low does it start, but when is the function going up? And as long as x is getting bigger, starting at 0, and as long as x is getting bigger and bigger and bigger, the y value is going up too. So the answer to this question, and I often use the acronym II for increasing interval, the answer to this question is the function is increasing whenever x is 0 or bigger. You don't have to worry so much about this parenthesis here. When we talk about increasing and decreasing intervals, just always use a parenthesis. It's a weird concept to be increasing at a specific point, so we never put a bracket there. We'll just leave it as a parenthesis. If you take a number theory class or something like that in college, you can get more complicated. The decreasing interval is a similar idea, except it's when is the function going down from left to right. And in this particular function, it's never going to go down. This orange arrow over here is pointed up, slowly, but it's up, and it's never going to turn around, unlike some other functions that we've seen and that we'll see soon. So we would say that this function does not have a decreasing interval. To give you a slightly better idea of what we mean when we talk about an increasing and decreasing interval, let's do it for an old function that we already know about, the absolute value function. So I want to know the increasing and decreasing intervals of the parent, just plain old y equals the absolute value of x. So first off, let's think about what this graph looks like. If that is the axis, then y equals the absolute value of x looks like this. It's just our plain old v. And we know its vertex is here at the origin. And so when is the function increasing? Remember, that means from left to right. I know it looks like we would say, oh, the function's going up on both sides. But we mean from left to right. So what you would have to do is picture yourself as a tiny little stick figure walking along this function. The question is, when is that figure going uphill and when is it going downhill? Always from left to right. So as this person walks to the side, he is going downhill until there, and then going uphill for the rest of time. So it's for the rest of time, starting at 0, is when our little friend is walking uphill. That's what we call the increasing interval. When he's going downhill? Well, he's going downhill now, but when did he start going downhill? He would have started going downhill all the way forever ago, as far back as imaginable at negative infinity, and he will always have been going downhill until 0. So the decreasing interval, we would say, is everything from forever ago, from negative infinity, all the way until x is 0. I want to point out something really important before I end this video, that 0 has nothing whatsoever to do with the y value. Had the function we were talking about been y equals the absolute value of x plus 4, where the whole graph would have been up here, the increasing and decreasing interval would have still been from 0 to infinity is increasing, and from negative infinity to 0 is decreasing. Because remember, these numbers here are x values. Doesn't matter how high the graph gets or how low, it matters when does it happen, which is always talking about x values. One quick thing back to our function, our square root function, which we've looked at a little bit. One last thing I skipped was the y-intercept. I want you to always remember how to find y-intercept. It's always, always, always the same thing. It is f of 0. I want you to kind of think that immediately whenever you hear y-intercept. Because the idea behind a y-intercept is what is the output when the input is 0, right? On this y-axis here, that's when the input, the x value is 0. So the question is, what is the output? Well, in our case, we already have it on our table. F of 0 is 0. So the y-intercept here is 0.